Good day, engineers. So, for this video, i-discuss natin yung steps sa analysis ng singly reinforced beam. So, this is still for reinforced concrete design na topic. So, start natin yung discussion with step number 1. So, according to step number 1, sabi dito, we always start with an assumption that tension reinforcement yields. So, we always start to say assume. So, lagyan lang natin ng lines. So, we always start to assume tension steel yields. So, lagi nating ginagawa or ina-assume na yung tension steel natin is mag-yield. So, with this assumption, we always say that yung Fs natin for our steel or yung steel stress natin will always be equal to the Fy. So, that is the first step in the analysis of the singly reinforced beam. Then, for the second step, we must determine the depth of the compression block A by using the statical equation or the statics equation C is equal to T. So, dito sa step na to, kakailanganin natin, kaya nilagay ko dyan, yung stress diagram. Kasi we need the value C is equal to T. So, ibig sabihin, we will be needing the figure shown or the stress diagram shown. So, we must have or we must satisfy the statical equation C. So, gamitin lang natin yung black. So, that will be C is equal to T. Yan yung kailangan natin ngayon i-satisfy na equation natin. So, for this one, we have AC. So, for example, rectangle lang yung cross-section natin. So, syempre, if that is rectangle, so rectangle yung cross-section, so we will have AB and we will have an H. And reinforce siya at the bottom. So, kung ganyan yung beam natin na kailangang i-satisfy or i-solve, so we will have a compression force na since ito daw yung susundin from the code, ito yung susundin na stress diagram kung purely rectangular siya. So, ibig sabihin, that will be a value C is equal to, syempre, that is, yung force is, galing lang yan sa force is equal to the stress, so let's say F, times our area. So, para maging force siya. So, ang stress natin dito is yung 0.85 of F prime C. Now, ano yung gagamitin nating area for our figure? So, syempre, kung nasa compression yan, we assume yung tension side nitong figure natin or nung rectangular na magkakrak na. So, ibig sabihin, ang itsura na lang niya is ganito. So, ang tendency for a 3D value is ganyan na yung magiging figure natin. So, that means para lang siyang volume ng rectangular prism. So, kung wala siyang kahit anong butas dyan, automatic, our area will be A times the B, which is yung base nitong rectangle natin or nung reinforced concrete beam natin. Then, for our tension, we will have syempre, that is, susundin nga natin yung force is equal to stress times the area. So, ibig sabihin, kung yung tension force na hanapin natin, since steel na lang yung nandun, so, ibig sabihin, ang gagamitin natin will be the area of the steel na nandun sa baba times the Fy. So, bakit Fy yung gagamitin natin? It is because of the first assumption that the steel is yielding. So, kung hindi man mag-yield yung steel natin, upon checking or upon validating, kailangan nating palitan yung Fy dyan sa part ng tension force. So, equating these two, we will have an equation 0.85 F prime C. Ang A natin dito is just theoretical kasi hindi pa natin sure kung true value yan ng A kasi nga kailangan natin i-validate yung yielding ng steels. Times B is equal now to AS Fy. So now, since equated na siya, we can have the equation for determining the value of A. So that is A theoretical. So, nilalagyan ko siya ng theoretical dito para masabi pa natin na that is for validation. So, that is equal to AS Fy divided by 0.85 F prime C B. Yan ngayon yung ating depth of compression block na theoretical na kailangan pa nating i-validate. So, for our step 3, so determine the value of the distance of the extreme compression fiber to the zero strain, which is yung C, or the distance from the extreme compression strain to the neutral axis. So we will use the NSEP section 422.2.2.4. So for this one, we will be using A theoretical is equal to beta 1 times C theoretical. So, syempre, yung beta 1 natin dyan, which is ito, syempre susundin pa rin natin yung nasa code na kapag in between ka ng 17 or 17 is greater, less than or equal to our F prime C or less than or equal to our 28 megapascals. So, ibig sabihin, gagamitin pa rin natin yung beta 1 as 0.85. So, our beta 1 will be equivalent to 0.85. Now, kapag naman that is greater than 28 but less than 55, so ibig sabihin, kukunin natin yung equation ng beta 1 which is 0.85 minus 0.05 times F prime C minus 28 over that is 7. So, that will be our beta 1 for this condition. Then, for F prime C greater than or equal to 55, so we will use a beta 1 equal to 0.65. So, yan ngayon yung condition natin for determining our beta 1. So, ngayon, syempre, meron tayong A theoretical. So, ang i-determine natin is si C theoretical for this step. So, ibig sabihin, aayusin natin yung equation for our C theoretical. So, we can have C theoretical is equal to A theoretical divided by our beta 1. So, yan ngayon yung equation natin for our step 3. Now, next, for our step number 4, we have to verify the assumption on the yielding of the reinforcing bars through the strain compatibility equation. So, ano si strain compatibility equation? So, for this strain compatibility equation, we will be using our strain diagram. So, syempre, i-drawing natin muna yung rectangular beam. Let's say that is a two-layered reinforcement. Tapos, syempre, meron niyang part na magko-correspond dun sa centroid ng reinforcement and magko-correspond dun sa first layer ng reinforcement. Then, for our strain diagram, so we could have at the top 0.003. Tapos, dito sa part na to, we could have the values. So, ito yung epsilon sub s and ito yung epsilon sub t. So, yan ngayon yung strain compatibility equations natin na gagamitin. So, from this figure also, we have from the depth or effective depth. So, that is from the extreme compression fiber to the centroid of reinforcement. And we have here C. So, dito sa strain compatibility equation na to, hindi natin gagamitin yung epsilon sub t. We will be using the epsilon sub s, which is the strain of the whole reinforcement. So, using the triangle form, we could have, ito yung height, which is d minus c. So, for ratio and proportion, we will have 0.003 over c is equal to epsilon sub s divided by d minus c. So, from this figure, we could derive the value for our uh, we could derive the value for our epsilon sub s, which is epsilon sub s is equal to 0.003 d minus c over c. Now, alam natin na epsilon sub s is a value equal to Fs over our Es. Then, substituting Fs over Es dun sa equation, we have Fs over Es is equal to 0.003 times d minus c over c. So, kapag itong Es natin, dinala natin sa numerator ng kabilang equation, we could have a value Fs is equal to, so, usog natin, so, Fs is equal to 0.003. So, substitute na natin si Es, which is 200,000 megapascal times d minus c over c. So, syempre, that will give you a value of Fs equal to 600 times d minus c over c. So, meaning, yung Fs na nakuha natin for this step, which is eto, is pwede nating gamitin in determining if our assumption from the first step is correct. So, this is the Fs theoretical kasi. So, Fs theoretical ang lalabas dito. So, ibig sabihin, if this one, so kung ang lumabas dyan is Fs, so kaya meron tayo ditong part A nung step 4, if bars are yielding, proceed to step 5. Ibig sabihin dyan, kung ang Fs natin na lumabas dito, which is Fs theoretical, is greater than our Fy, therefore, tama yung assumption natin, or we have a correct assumption that steels are yielding. So, this is, nilalagay natin yan as therefore, steel yields or SY. So, ibig sabihin, yung A theoretical na na-compute natin kanina ay siya na din yung A true value. So, ibig sabihin, tama yung A na kinumpute natin kanina. Kasi nga, tama yung assumption na steels are yielding. And also, yung C theoretical na na-compute natin kanina is also the C true value. So, that will be the part na kung saan tama yung assumption natin at nakuha na natin agad yung A true value at C true value. Ngayon, pag tama din yung assumption mo, we can say na yung Fs theoretical na compute natin kanina is equal to the Fs actual or the Fs true value. So, this is ito yung kino-correct na natin yung assumptions natin kanina. So, ngayon, hindi natin siya kailangang i-correct kasi nga, tama yung assumption. So, for the next part, paano naman kung nagkamali tayo ng assumption? Paano kung ang lumabas sa Fs theoretical is mas mababa siya kaysa kay Fy. So, ang mangyayari is ganito. Therefore, pwede natin i-conclude that this one is still does not yield. And we can use this step for point B, which is, sabi dito, if bars are not yielding, determine the actual value of the depth of the distance to the extreme compression fiber to the zero strain by replacing the steel yield strength with the stress compatibility equation in the statical equation C is equal to T. First, get the actual value of the depth of the compression block, which is A, by the NSEP section 422.2.2.4.1. And second, determine the actual value of the steel stress by the stress compatibility equation. So ngayon, ang gagawin na natin, since for this part, mali yung assumption natin na steels are yielding, so syempre, i-correct natin yon. Babalik tayo ngayon on step number 2 dun sa statical equation, which is C is equal to T. Ang itatama natin na part dyan is yung part ni Fy. Hindi na natin siya pwedeng gamitin. We will use the part Fs or the equation for Fs. So, ibig sabihin, ang magiging equation natin will be a value 0.85 F prime C A B is equal to AS Fs. So, ang gagamitin nating Fs dyan na equation will be, ito is yung Fs na na-derive natin from our strain compatibility equation. So, ibig sabihin, we could have an Fs equivalent to 600 times D minus C over C. As you can see, meron tayong dalawang unknown dito sa equation na to, which is yung A at yung C. So, hindi natin sila pwedeng pagsabayin kunin sa iisang equation. Kasi meron lang tayong iisang equation, pero there are two unknowns. So, ibig sabihin, magdagdag pa tayo ng isa pang equation, which is yung nasa NSEP na equation na A is equal to beta 1 C. So, from this one, we could now have 0.85 F prime C beta 1 C times B is equal to AS times 600 times D minus C over C. So, simplify natin tong equation na to. So, we could have, so, syempre, multiply natin both sides by C para mawala yung denominator nung nasa ilalim. So, we could have a value that is 0.85 F prime C A B or 0.85 F prime C beta 1 B C squared is equal to AS times yung 600 ipasok na natin dun sa loob ng equation. So, ito siya. Pasok na natin yung 600 kasi magka-cancel na to eh. Kakancelin na siya. So, 600D. So, that is 600D minus 600C. Ngayon, simplify natin tong equation na to further. So, we could have 0.85 F prime C beta 1B C squared is equal to 600 ASD minus 600 ASC. Then we arrange this equation. So we could have 0.85 F prime C beta 1B C squared. So, lipat natin yung 600 ASC dun sa kabila. So, that will become positive 600 ASC minus, ito, ililipat din natin. That is 600 ASD is equal to 0. So, as you can see, meron na tayong quadratic equation. So, to solve a quadratic equation, we should have C is equal to negative B plus or minus square root ng B squared minus 4AC over 2A. Yung C dito, yan yung hinahanap natin na depth na distance from the extreme compression fiber to the zero strain. Yung C na nandito sa loob will be a part of our quadratic equation. So, isa-isahin natin. Yung A dyan, that is for the 0.85 F prime C beta 1 B. Yung B dyan, that is equal to 600 AS. Then yung C natin will be negative 600 ASD. So yan ngayon yung way natin ng pag-solve ng quadratic equation. And remember, dalawa yung ilalabas niya sa yung sagot kasi it will be plus or minus the square root of b squared minus 4ac. Pwede rin natin gamitin yung shift solve sa calcu, pero be careful in using the shift solve. Much better na wag tayong mag-shift solve 0. Much better na lagyan natin ng value na positive. So, ang ilalabas sa atin ni calculator is a positive value. So, let's say, i-shift solve nyo, then, ang gamitin yung value is yung depth ng beam or yung height ng beam. So, that will be the first part of this video for the steps in analyzing a singly reinforced beam. So thank you for watching. Again, this is Engineer Rodolfo, and don't forget to subscribe to Butch TV.